In this video, we're talking about direct variation, and sometimes you'll hear it called direct proportion or direct ratio. But all it means is that one thing varies directly with another, which means that if one of the things increases, the other one increases, or if one of them decreases, the other one will decrease. In another video, we'll talk about inverse variation, where if one of the things increases, the other one decreases, and vice versa. But when you talk about direct variation, they're both going to increase together, or they're both going to decrease together. They always move in the same direction. So a really simple example of this would be boys and girls in a classroom. So let's say I have boys here and I have girls here. And I tell you, there are always twice the number of boys as there are girls. So for every girl, there's going to be 2 boys in the classroom. There are 2 times as many boys as there are girls. So those are all different ways of saying the same thing. So if there's always twice the number of boys and I tell you there's 1 girl, then you're going to be able to tell me that there are 2 boys. If there's 2 girls, then there's going to be 4 boys. If there's 3 girls, there's going to be 6 boys, because there's always twice the number of boys as there are girls, so you just take the value for girls and you double it, and you know how many boys are in the classroom. As you can see here, we're increasing the number of girls, and when that happens, we increase the number of boys. So because both of these values are increasing, we can say that there's a direct relationship between boys and girls, and that's what we mean when we say direct variation. Boys and girls in this example vary together because they're both increasing, they're moving in the same direction. Now, the formula that we always use to describe 2 variables that vary with each other, that vary directly, is this formula here, x equals ky. This is the formula that we always use for direct variation, and it tells us that x and y, the variables x and y, vary directly. They move in the same direction. They either both increase or both decrease. K is a constant that describes the relationship between x and y. Now, I could also write this as a equals k. B, I could write it as M equals Kn. I could write it a bunch of different ways. The point is that K is going to be our relationship, and X and Y are the 2 variables that are related to one another directly. So let's look at this problem that we've been asked about here. It says, if the number of teachers varies directly by the number of students, and there are 5 teachers for 150 students, how many teachers will there be when there are 300 students? Okay, so we can see right off the bat that we have a relationship between teachers and students. We know we're going to need to use our direct variation formula because the problem tells us that the number of teachers varies directly, right here, varies directly by the number of students. So we know this is the formula we're using. We just have to assign teachers to one of our variables and students to one of our variables. Now, it's important to be consistent here. It doesn't matter whether we assign teachers to X and students to Y, or vice versa, students to X and teachers to Y, as long as we keep this consistent. So let's go ahead and say that students is going to be X. So I always recommend writing down a little key for yourself here so that you don't change midway through the problem. So X is going to be students and Y is going to be teachers. Okay, so we always have to remember that. So now it says there are 5 teachers for 150 students. So we want to plug in 150 students for X, so we're going to get 150 when we plug this in for X right here. It's going to be equal to, we always leave K, and then we know we have 5 teachers. Teachers is Y, so we're going to plug in 5 for Y, so we'll say multiplied by 5. So we're going to get 150 is equal to 5K, and then we're going to divide both sides by 5. So we're going to divide by 5 and divide by 5. We'll get 5 to cancel over here. 150 divided by 5 is 30. So we get 30 is equal to K. Now the goal with these problems, if K is not given, the goal is always going to be to solve for K. You're going to need a value for K in order to answer the question that we've been asked. The first thing we needed to do was find a value for K, and we did that. Now with a value for K, we can answer the question. So the question is, how many teachers will there be when there are 300 students? So again, we need to plug in 300 for X because X is equal to students. So 300 is going to be equal to, now we have a value for K, so we can plug this in for K here, so we'll get 30, and we want to know how many teachers. Teachers is Y, so we're going to leave Y in there as a variable. Now, to solve for Y, we just divide both sides by 30. We'll get 30 to cancel over here, and on the left-hand side, we get 30 over 3, which is 10. So 10 is equal to Y, which means there are going to be 10 teachers when there are 300 students. And this should make sense, because if we draw a little chart here like we did before, and we have students and teachers, we said we had 150 students and 5 teachers. 150 students and 5 teachers. We know that the relationship between teachers and students varies directly, and we want to know how many teachers there will be when we have 300 students. So 300 students, and how many teachers are there when that's the case. We know that they're going to vary directly, and we saw that with students, we just doubled the number of students. 150 times 2 is 300, so we doubled the number of students. If they vary directly, we should be doubling the number of teachers. When we double the number of teachers, 5 times 2 gives us 10, so we get y equals 10. So that's sort of a logical way to do it without the formula, but it's really important that you know the formula because the problems aren't always going to be this simple. Now, one thing you can do to test yourself is flip the variable assignment, make x equal to teachers and y equal to students. When you do that, you'll plug in for x and y as we did in this equation here, but you'll get a different value for k. You'll plug that value for k into this other equation, but when you do, you'll end up getting the same value for teachers for 300 students. It's just a reciprocal value of k when you flip the variables, but that's still an interesting exercise to prove to yourself that it doesn't matter whether you assign teachers to x and students to y or vice versa. As long as you stay consistent, you'll get the same answer when you use this direct variation formula here. So that's how we use the direct variation formula to model the relationship between two variables, x and y.